Hello, this is Miss Cummings. I'm going to continue where the other algebra teacher left off. A function can also be a rule with input values the domain and output values the range. I'm going to make a chart over here in X and Y. X can be known as input, Y is output. X can also be known as domain and Y as range. So when they are giving you the domain, they are giving you the X's and they're wanting you to find the Y values. You have the rule 2x plus 3. Function notation -1, f of -1. Your rule is 2x plus 3. This would be, you're inserting the -1 in for x. So when f of -1, y is 1. F of 0, 2 times 0 plus 3. Apologize for that extra mark. 0 plus 3, which is 3. F of 1 equals 2 times 1 plus 3, 2 plus 3, which is 5. Coming up here, f of 3 equals 2 times 3 plus 3, which is 6 plus 3, which is 9. My range in set notation usually goes from least to greatest, which is 1, 3, 5, and 9. Ordered pairs, set notation. When I inputted -1, it gave me 1. When I inputted 0, the output was 3. When I input 1, the output is 5. When I input 3, the output is 9. Function notation, f of x. F of x is a fancy name for y. The reason you use that is to distinguish which equation you want to talk about. To find -1, you replace x with -1. Therefore, you have 2 times -1 plus 3, -2 plus 3, which is 1. So you could actually write this as y equals 2x plus 3. Find the range values of each function for the given domain values. Range is a fancy name, is another name for y, given the x values. You're going to do f of -2 equals -2 squared minus 3, 4 minus 3, which is 1. F of 0 equals 0 squared minus 3, which is -3. F of 2 is 2 squared minus 3. Said 3, didn't write 3. Let me make that a 3. 3, which is 4 minus 3, which is 1. F of 4 is 4 squared minus 3, which is 16 minus 3, which is 13. Now, notice I have f of x and now I have g of x. The reason we use function notation is if I had an equation y equals x squared minus 3 and I had y equals -2x minus 4 and I say plug 1 in for x, you would go which equation? But if I can say plug f of 1, find f of 1, you know exactly which equation I'm talking about, which is this equation. But now if I said g of 1, you would know I needed to plug in 1 for that. So the function notation lets us distinguish different equations. Okay. G of -4 equals -2 times -4 minus 4. 8 minus 4 is 4. And then I have g of negative 1, negative 2 times negative 1 minus 4, 2 minus 4, which is negative 2. G of 2 is negative 2 times 2 minus 4, negative 2 minus 4, negative, can't multiply, sorry. Let me do that one again. Negative 2 times 2 is negative 4 minus 4, which is negative 8. And g of 6 is negative 2 times 6 minus 4, negative 12 minus 4 is negative 16. Okay. So it says find the range values, which I did. In this first problem, I could actually write this as the range, and I'm going to list them, and I only list them once, and I list them least to greatest. So the range of that rule is negative 3, 1, and 13. Notice there's 2 ones. I only have to list them because in set notation it says any of these are appropriate. And so the range of this guy down here is 4, negative 2, negative 8, and negative 16. So it would be negative 16, negative 8, negative 2, and 4. I'm going to stop the video, start another video for the next page.